Well, hello everyone and welcome into another live stream. Hi there, Happy. Don't you even worry about it. It is fine, it's alright. As long as you answered, it's... Yeah, I really like this new you, Happy. I really do. I'm really glad to see you change for the better. And I've gotta say, I appreciate it. I really do. Today, hello everyone, by the way. Hi there. Hi, no, hi. Welcome everyone. Hello. No, I'm still not used to this. Like, there's an echo in my office right now. I cleaned it up 2 days ago, and I did it so well that I actually changed the acoustics, so... yeah, now there's an echo. Wow, I'm still not used to it. Anyhow, hi there everyone. Let's have a sip. OBS Studio disconnected. But why? So, hello everyone, welcome to another live stream, and today we'll be doing some 3D. A lot of 3D. A fair bit of 3D. Well, not really quite a lot to do, only I have 2 or 3 animations which I really want to do on stream because I thought they would be fun to make. I'm gonna go in a bit because I have the rest of my finals tomorrow, so I need to go study. Oh, it is final, and good luck. Good luck. I believe in you. Changing for the better. This is sad, mate. Changing grows person mentality. Oh, cringe, making world a better place, am I right? Recently, my video has been blowing up again, and I think that's actually because people are finally done with their exams in school and more. I think that's why. That would be my guess. And if that's the case, then that means it's gonna actually stay up, and that means I might actually have some money to spend on videos. Wouldn't that be fun, huh? Anyhow, so hello everyone, and welcome into another live stream. And today we'll be doing 3D. I'll call it now. There we go. Let me just stream Blender. There, default cube. How festive. And also another thing is I'll have to disable this desktop audio and I'll have to enable music, because I'll be actually animating all of this to the text I recorded earlier on, and I don't want to spoil the video. I think I'll make it doesn't check Discord, so what happened earlier? I do check Discord, I just don't check Cole's channel. That's the only one I don't check. Because there's just a lot of it. Right, now what we're gonna do is we're gonna then... I think this is the right one. There we go, I think this is the right one. I think you should be able to hear the music now. Sick! Neat. So, let's go for it. Physics Universe. Hi, the Physics Universe. Make it. This me. Let's start by deleting the default cube as you always do in Blender. Tradition is very important to delete the default cube. Hold on, let me just check if you really can't hear this. Okay, yeah, I'm pretty certain you can't hear this. There we go. Sick. I don't want to spoil the video. I want to make you sad, but it takes a lot of effort. I can hear the music. Yeah, that's good, that's good. Only music is supposed to... Yeah, yes. Hold on. First of all, let me just... I don't always forget. There we go. That's how. This is gonna be a bit more of an elaborate video. That's why I'm gonna actually animate all of this to the sound in the background, instead of doing the other way around, recording the sound and then animating, and then doing this. It doesn't matter. The point is not irrelevant. The point is we're gonna animate today, and for that we'll have to first start with a certain style. We'll have to get a bit of a style for this, and what I really often like to do for the intro, first of all, 4096 because of the intro, and we're gonna make it look cinematic. And when I say cinematic, I mean it's gonna be good. So Hello everyone, welcome into Make It's recipe for cooking up some cinematic animations. Step 1. The floor. The floor is important because the floor is most of the time the only thing you can see. So we want a good floor texture. A really good one. Hi the ramen cart. Hi, welcome. We're making an animation today. A festive one too. So, first of all, this Make It's recipe for a cinematic animation. When it comes to the floor, it doesn't really matter, but I would recommend something metallic and something with a little detail to it. So like this, basically. This, then one displacement, certainly. Wait, no, that's... Yes, displacement. There we go. Displacement right here. Or maybe, was it scale, I think? There we go. And now roughness, also very important. And one last thing, which is metalness. There. And now if we take a texture coordinates, if we map it, all of those, then yo, make it. We have a challenge where you have to do a video in 75 hours. Did you make it? Wait, 75 hours? You mean like, oh yeah, I did. Wait, it was a while ago. Oh, that was quite some time ago, wasn't it? Make it, I'm gonna come back to the live action video style. I am so glad you asked. I swear I remember making that 30,000 subscribers. What happened? I had 16,000 and it was stuck on it actually. And only recently the additional quantum mechanics video blew up again. And now we're at 17,000. Finally! Gotta move on. Took a while. Oh, I'm really hoping we'll keep that way because otherwise I'll just go broke. There we go. Thick. My final exam. It's fine. I think it was the... Oh, what was the video? It was before the chemistry. Was it? It wasn't computers. It was... Oh, wow, it was a while ago. I think quantum mechanics for chemistry? I don't remember exactly which one. The point is, right here, let's crank that bad boy up to something like 20. Now, here we have a lot of textures mixed together to create a single one. Why? Well, I'm so glad no one asked. You see, what's really nice about mixing these textures together is that if you actually have like a single light source, something like a text, something like subscribe, for example, then we can give it some extrude, and then we can give it material, we can give it emission, and look at that. Now, isn't that already just straight up swell? And that's just the texture. Like, that's already a pretty decent render. Hold up, render. Can I render like this? Oh, I can. Festive. There we go. That video is like carrying the whole channel. It really is. It has more views than the entire rest of the channel combined. It is insane. It's really insane. But there, we already have a pretty good looking render, but it's not cinematic enough. So let's crank it up a bit. What we can do is we can, for example, add a cube. Make it a bit large. There we go. And then we can give it volume material, which means removing this, adding a principal volume. Now everything's gonna go dark, so it's 0.08 for my normal use, but then depending on the distance, of course. And then we can take this and we can actually give it some larger brightness, and keep forgetting I have to switch to the render tab. There we go, bit better. 70% of making subscribers are inactive and subscribed for one reason. Mathematical magnet, this is sad. I mean, it is true. It is true. Statistically, if you've seen the addition to quantum, statistically, most people that have seen addition to quantum mechanics video have never seen anything else on the channel. That's most people, which is, well, interesting. I think that video might have more likes than I have subscribers, actually, which is once again also pretty funny. Yes, don't worry, we'll get them next time. Soon we'll get them. So we'll make a good animation. But yeah, this is what we have so far. And this is decent. This is like, I would say decent. Let's up the cinematicness a bit. Well, let me check the script. It's like, so right here, what we want is camera to be up, camera to be forward, camera to be back, and even further back. And then what we want is a sphere going up, and then we want it to right here is where we want it to light up. And then this would be bounce. The map era is gonna save us, make it. The chemistry era is gonna, I'm really hoping for it. Make a map series. Oh yeah, I am trying to. I actually asked two different, because the whole point of that map series is that I want to do it with other people, right? I want to do it with other people. And I asked two different people to make a video with me. Both of them said yes. Okay, so the interaction for both of them looked like this. I messaged them. They messaged me back being like, yeah, probably we'll make that video. Could you send in the details? Then I sent in the details. And then both of them just ghosted me. They just... That's it. That's where it ended. They both just stopped responding. And I don't know what to do. Should I send another message? Maybe. I just don't know what to do. I feel like it's a me problem because it's two different people, but it doesn't feel right. No, it doesn't feel good. Okay. Next what we're gonna have is a cable. Oh, this is actually gonna be a pretty cool animation. Hold on. Let me just find curve right here. And also the volume will be disabled for the non-render. Does Tefta know any math stuff? I mean, Tefta knows electronics. A lot of electronics. I don't think math stuff. I mean, Tefta doesn't know math stuff. It's just that Tefta knows math stuff on like my level. And I want to do it with experts who are way further than my level. There we go. Oh, beauty. And now we're gonna have a shoot for the stars. Ask Freeborn Rogue. I mean, I could ask. I don't think I'm gonna respond back then. I could, but I don't have a video that's good enough to be actually worthy of Freeborn Brown. I don't have a video idea that would be, you know. Okay, maybe one. Let me think. What map video can I make of Freeborn Brown? Huh. That's a pretty good question. Ask Veritasium. Once again, can you... I don't have a video as good... Well, I do. I do have one video which I could make Veritasium, which I think would be really, really fun. But that video would just cost me a lot of money. And when I say a lot, I don't mean a lot for my current standards. I mean a lot. I feel like the whole budget for that sort of video would be around $5,000 to $10,000 in order to actually make it work. So I do have an idea, and I am gonna make it. It's just that, you know, we first need to earn some money to that. Yes, material, but that's gonna be copper, not copper. Copper. Anyone knows any things you can do with sulfur, by the way? I have so much sulfur. I don't know what to do with it. And not sulfuric acid, by the way. That's dangerous. I don't want to die. Anyone knows any things you can do with sulfur that's not sulfuric acid? I am in need of assistance. I know a lot of chemists, but I don't really know. I mean, I know chemists, but that's mostly Flame and Harry. And Harry is more specialized in electrochemistry, and also I don't want to bug him too much. And Flame is more specialized in like quantum chemistry. Oh, they can get that. It's already phenomenal. Now we're just gonna add like this, metallic up, roughness down. Ooh yeah. Ooh yeah. Oh yeah. Cool looking fire white sulfur. You mean like burn it? Yeah, but I have so much sulfur. I have so much sulfur. It's a problem. It's a genuine, honest problem at this point. I don't know what to do with it. It's just too much. Just straight up too much. Alright, so right here we can make this bit shorter. And then we can apply this array. And the reason why we would want to apply this array is because right here is where we would like this to move. There we go, and now right here start. Hello, hi there, random guy. PBS Space. I also think a view of PBS Space Time. Oh, PBS Space Time. I know from somewhere. It's PBS Space Time. PBS Space Time. I've heard that. Oh, I know where I know them from. It's like the... Okay, yeah, I've seen a couple of their videos pop up. That's also maybe, but you know, they have 3 million subs. Listen, one day I'm all for it. It's just that I don't really have much of a bargaining power right now. Most people would just tell me. The thing is, I just don't have a budget. If I had a budget, that would be so much easier. Make car batteries, fertilizer, or refining oil processing milk extraction. Wait. No, wait, hold on. Well, car batteries. For car batteries, you need sulfuric acid, if I'm not mistaken. And making sulfuric acid with sulfur is surprisingly dangerous. Sulfur uses. Let's see. What are uses for sulfur? Properties and uses. Alright. RSC. So, used in vulcanization of black rubber, fungicide, or black, and in black gunpowder. Most sulfur are used in production of sulfuric acid, which is probably the most important chemical manufactured by Western civilizations. Yes, sulfuric acid is really everywhere. Phosphor uses the manufacture of phosphoric acid to make phosphor. Yeah. Gas and smell. Sulfites are used in bleach paper and as a preservative. That's sulfites. I can make sulfites. Calcium sulfate is mined. Oh, they are mined, which means making them probably be inefficient. So there isn't really anything cool I can do with sulfur except for sulfuric acid. Home defense system using sulfuric acid. Yeah, but I can't really make sulfuric acid from sulfur. That's the biggest issue. Because whoa, that's so wrong. That is so wrong. Hold on. I know how to fix it. The main problem with making sulfuric acid using sulfur is that there's like a... Oh, damn, I'm good at this. That you make basically what you do is you take sulfur, you burn it to make sulfur dioxide, SO2, I think, is that how it is? I think SO2, and then you oxidize it to make sulfur trioxide. And this right here is deadly. And so I don't want to die. This is a personal thing of mine. I'm not the biggest fan of dying. That I really would make sulfuric acid out of it, but I can't, because, you know. Despite the odds, I could make it this stream. Well, I'm so glad you did, Hungry. This, and then color rump, and then muff, and then right here emission. There we go. Okay, so this is supposed to be a cable through which electricity flows, which means what we basically want is we want this right here, strength 100. Why is the mode? Wait, why are the mode? Oh, that's why there's multiple ones. Oh no! Can you do it before applying the curve? Oh, I think it's because this is object. Wait, am I right? Am I right or am I right? I am so smart and right. Okay, first if I just need to make this a lot smaller. And for the color, it's going to be yellow. Making yesterday's stream was fire. I'm really glad you like it. It was fun. It really was fun. Could you make it? Is your charity going on a lot of, raise a lot of funds for it? It's not really. Is your charity going on well after? Were you able to raise a lot of funds for it? It's not my charity. I'm collecting money for charity. DBS Alliance. Link on the screen. HTTPS console to make it obvious. Starting go to my charity and guys buy for yourself. But yeah, we have been streaming every single day for the past 462 days. That's a lot of time, actually, to stream every single day for. Wow, that's a lot of time. Wow. I still remember like the first week when I was like, oh yeah, I've streamed every single day for a week. But you know, that's not that impressive. It's not that difficult to stream every single day for a week. It's been over 1.5 years. We do more streams like that, 3 hour long and no paying attention in the chat. Oh, I was paying all attention to the chat. I was paying all attention to the chat. Yeah, we're not a good influence. What do you mean? It's not time. Do you think it's worth it? Yeah. I mean, my time isn't worth a lot right now, so you know. Okay, so what we want right here is we want this to be this keyframed, and then right here we want this to go on. And then what should happen is, what you should see happen is this moving forward, the cable. Oh no, that's moving. Oh, that's not great. So basically, kind of right here's where we want it to begin. How about now? There we go. Neat. Now let's see how it looks. In the render. Thanks, Frankie, for removing my ball. It's just because the great hat music was related to Ali Theft of helping make it get smarter. Being happy for this, being positive. I really like that. Make it plushy when I don't know. I don't know. Would we get a when we get more subs? That's a guarantee. Make it. What do you think about the increasing gap in ideologies in males and females? I think like that's such an artificial gap in ideologies. Because it's not really. It's just that you have certain like echo chambers where people think that that's the case, but it's not really. So you have basically 4 right groups, and then you have also I can't really think of that many for the women. We men tend to go everywhere, so you respect the hustle. Has it become so routine for you? A bit chaotic with the streaming. It is both. It's both. It's a bit chaotic, but I always have it in the back of my mind that I have to stream, so kind of used to it by now. There we go. That's enough for render. What's next? Now we need to actually we're gonna keyframe this, and right here we're gonna move it backwards and have it face a bit more down. And then up like this. Are you on university now? Finished university? No, neither. I just research stuff for fun. And the streams also do help. The fact that I like force myself to learn stuff on stream, that also helps. So like it's too negative, and you gotta restart, go back to the happy place at the beginning. Just I get you're just being happy, so that's that sadness would hit hard. Wait, you're not in the university? No, not 3D chemistry stuff. Flame, this is the video. You remember the video I sent the script to? Like, you can, because you have access to the script, right? The video, yes, this is the video. This is the original intro. This is the intro to the video. That's what I'm making right now. This is gonna be a pretty good one. The script looks good. Yeah, I'm really excited for that video. It was such a random thing. For those who didn't know, 2 days ago, I think it was 2 days ago, I streamed with Flame. And Flame got me really excited about something. But I don't know if I want to share what it is yet. I mean, you can already figure it out based on context clues, but you know. Don't spoil it for anyone else. I've been missing for a couple of days and I come back to Sadie Happiness arc. Yeah, the world's changing quick, mate. We gotta keep up. I'm really scared though. Spoilers, yeah? Yeah? No one do know. I mean, patrons do know. Patrons can know. But you know, that's patrons. I'm really scared though. Because the quantum addition to quantum mechanics video has been blowing up again. And like, damn it, right now I don't want it to stop. Right now it's gonna stop and I'm gonna be sad. Damn it. I don't like it. I don't like it. Now I'm tense. I know, I'm scared. The video won't perform well again. Yeah. Alright, then we're gonna have this, which is gonna be like a little red dot. Red. I think I was 3 for these, if I'm not mistaken. And then right here we want it to be negative 5. And then 1. And right here we want this to go to 0. And then 1 and 2 move in. Just like this. How they're excited all for upcoming content to just ask to support your work. How you were right? No, you are right. That is very awful. Hi, the lamppost, by the way. I'm assuming you're. Hold on. Wait. What do you feel like the main reason for the addition to quantum mechanics video blowing up was the thumbnail and quantum mechanics in the title? That's obvious. That's not even. No, that's like. Yeah. Do you feel like the algorithm just really randomly blessed it? Well, it blessed it because of the thumbnail and the title. But yeah, it's an ED algorithm. There's no doubt about that. The click rate on that video is actually lower than my other videos, which is, I think, funny. In non-unis, you just learn all this crazy stuff. Yeah, I just do on stream. I'm bored. That's why I do it. Keep creating new accounts and I still find my feed when I search scientific stuff. I think you're single-handedly lowering my click rate. Kind lamppost, there's probably a ton of factors. Yes, but it's all up to the algorithm at the end of the day. Let's take a moment to pray to our Lord and Savior, YouTube algorithm. May they bless us with views and watch time and ad revenue. Mostly the ad revenue. The click rate is low and doesn't it mean that it's not the thumbnail? No, because... Okay, this is a bit confusing, but basically... when it comes to click-through rate, right? I think on that video it was like 3.6%. It was something around the 3. On my new videos it's around 5%. And so, whilst yes, it is lower, it's lower to a broader audience. So whilst all of my videos right here get around 50,000 impressions, this video got like 4 million. And so, because of that, basically it is a lower click-through rate, but that's because the algorithm has shown the video to people who are less probable to click on it. And the reason for why the algorithm shown this video to people who are less probable to click on it is because of the thumbnail and title. This is the algorithm. We just have to pray to our Savior, to the one who gives, the one who takes, the one who decides, the one to rule them all. No, I always click your videos when I see it. Never mind then. Then Happy is responsible for why my click rate is so high. Yeah, Happy is. The main reason your quantum videos bad because of the simplicity with which you explain integration using probability using integration. I really like how I really like that, the fact that I explained them, because I'm really proud of that, not gonna lie. The fact that I did a home run with probability and integration at the same time. I think it's funny. But it's unavoidable actually when it comes to calculus. If you want to define derivatives, you do it in relation to the limit. If you want to define limits, you do it in relation to the derivative. There's always circular. Like you have basically the wait, dx. Wait, am I? Yes. Okay. So this is defined on the limits, and limits are defined on this. It's circular. It's really funny. I find it's pretty funny enough. We need to do a 10,000 atoms giveaway next video to get more views. For each of my subscribers, I give thee an atom. You pick which one. Oganesson, great choice. Man, you know the algorithm. I mean, it's not that difficult to know. It's like... you know the algorithm more than knows you. That's pretty fun. It's not that difficult to know. It's just... Once you realize that algorithm isn't made for the creators, it's made for the people watching the videos, which makes sense, right? Like, YouTube, at the end of the day, isn't making money on the creators. YouTube is making money on people watching the ads. So, it makes sense that the algorithm, you know, is made to keep them watching as much as possible, not to give creators the exposure. When you realize that, then it all becomes pretty obvious. Smaller. One. Ah, damn it. I screwed up. Alt P. Control P. I still remember when it put on my feed at 4 in the morning. I was halfway through the video and I decided to watch it again to make notes side by side. I really want to remake this whole thing because I don't like that video anymore. I mean, it's a good video, but it's not really 300,000 views kind of good, you know? Lamppost, you mind not doxing people? Please, mate, come on. Beware, he doesn't use malls. Malls are not necessary. We'll need more. Malls are pointless. And Flame, remember what you said about me malls in the video? I switched up. I don't even use the Avogadro's constant because it's pointless. You don't need the Avogadro's constant. The Avogadro's constant, like, mall fails as a unit, and my goal is to also prove that it fails as a constant. It just fails. That's what I set out to do. That's what I want to do. Mole is the best constant. Please don't hit me. I don't even think Mole works as a constant anymore, honestly. I really don't. I don't see a point. I honestly believe that, like, 10 to the 24th power would be better than Avogadro's number. I honestly believe that right now. Mole is overrated. It really is. What matters is you having fun for 162 days consecutive. Recognize your life, and I don't know, you mood thoughts. I mean, it has given me a lot of consistency. So, streaming every single day for 462 days, it made my life a bit more consistent. And I like that. I hope you know Africa. Africa is a continent. What? No, you mean Australia? Africa doesn't exist. They made it up. They just don't want us to go. They just don't want us to find. They just don't want us to find the big Arctic wall. You know, because on the flat Earth you have like a. You have like an Arctic wall around it, and they don't want us to find it. So you know. Isn't Mole technically a base SI unit? Yes! That's what's so dumb about it! It's not only... First of all, it fails as a constant. Second of all, it's just straight up dumb as a unit. And for some reason they made it the base SI. They could have made Bells a base SI unit, but no! They picked Moles! I am upset. Okay, the point is... Mole's agreement mixing dish. I don't know why I have so much. New concept proposed new Obama will be equal to 69 atoms of every element. Every single one. That'd be a good unit. 69 atoms of every possible element. Ions and isotopes included. Flame, please don't even go again. No, okay, I'm done. Chemistry student. Yeah, but Mole just does. Mole is pointless. It's so pointless. It's so gosh darn pointless. If you need to use Mole, like really need to, then I would just reevaluate your life choices because you don't need to use them all. Don't let them lie to you, okay? Don't let them lie to you. They want you to use them all. They make money off of it. Well, you think the SI system would make money if you weren't using their units? No. That's why they want you to use them all. Don't give them the satisfaction. Oh, this is gonna take ages to render. Jeez, Louise. Wow, this is really gonna take ages to render. Okay. Okay, so right here we're gonna have 0 density and 0 emission strength. Emission color is gonna be yellow, and then right here we're gonna have 1. We're gonna have 1.6. Don't give big SI what they want precisely. The guy who made Mongols was absolutely tired of his job. I really don't get Mongols though. I really don't. I mean, I get Mongols. I don't get the point of them. Mongols based off carbon, right? Why not hydrogen? Why of anything? Why not just why use the Avogadro's constant when you could use, I don't know, 10 to the 24th power? You could just use this, and then you basically wouldn't have, and they basically molar mass would be so much better, because then what molar mass would basically tell you is, hold on, it would basically, molar mass would basically tell you the mass. You could basically get a mass of a single particle in your head. You could just do that calculation in your head, because you would just need to add a prefix, and you can get a mass of a single particle. It'd be so much easier. The same thing with amperes though. Why is Coulomb so weird? Round it up! Round it up! So easy! Would make everything so much more consistent. Me not using moles chemistry now. You don't, I mean, you could do it without moles. It's not difficult to do it without moles. Whenever your teacher would accept that, that's up to debate. Depends on the teacher, I suppose, but you don't have to use moles. There are ways around it. You can just, for example, use single particle masses if you want. That's what I do. And then negative 0.2. And then back. Okay, those. These are just hidden mathematician. The most of them really are. Avocado. Yeah, that would also be my bigger improvement. Make it. Why did you not go to uni? You felt like self-learning better? Because I said chemistry better than my teachers though. Well, I didn't go to university because I don't really see a career path for me after university. I don't see a single job I would actually feel happy doing. That's why I didn't go. So for me, it's kind of pointless going to a university. I'm a generalist. If I was gonna... specializing, I don't like the idea of specializing. I've completed all chapters of physics and chemistry. I need to prepare for examination. I'm going to give, but can't do some of them. What should I do? Moles do insanely help with convenience, but it is a bit of a funny unit compared to pharmacy doesn't, instead of giving the exact number. Yeah, I mean, I don't really get why Avogadro's... Maybe you can help me clear this up. Where does Avogadro's number help? Like, where... Give me an example of a scenario in which this is better than this. I just need an example. Because I honestly don't get it. I really do not. And then watching live stream. Oh yeah, we really are high. Hi there, Crimpy, by the way. I forgot the street name. The practice question and then we're gonna come to ask your question if... I'm here because of my own will. I am not being threatened. Precisely, Hungry! You're not being threatened. So how about you just like the stream and subscribe? How about that, huh? Because fine, you're here because you like it. I'll just recommend it. Okay. Math. No. That was number helps me in exams. I don't get it. I need an example. I need an example of where Avogadro's number would actually be better than 10 to the 24th power. Because when it comes to water, for example, the mass of a single molecule of water, H2O, that's, if I remember correctly, 29.9 octograms. And if you use the Avogadro's number, figuring out the molar mass is like really difficult. But if you use 10 to the 24th power, then the molar mass of water would be equal to 29.9 grams per, well, in this case per nothing, honestly, because, you know, it's a number. Just like the fucking mole is. But in this case, if you really want to call it, but then this would be the molar mass of water, basically. Right? That's... Doesn't that seem better? Am I the only one not taking my pills in Crazy Town, or am I the only one taking my pills in Crazy Town? You can have the mass of a single molecule, and then based off it, you just throw the yocta away, and you get the molar mass. And you can also go the other way. Oh, you only know the molar mass of water? Well, how about the molar mass of a single single molecule? How much would that be? Easy, just add a Y. Isn't that easier? I feel more productive watching him. I don't know why it looks like a good coder video. Thanks, make it. I am really... I do get that often, actually. A lot of people feel more productive when they watch me do stuff. I don't know why, but I'm here for it. Let me make it just add revenue. I am vessel wishes. I regret having to read that. I'm checking those to find examples of Avogadro's number being better than the round number. I just need one. Just one example. It doesn't make sense. No, there's no way. They wouldn't just, Avogadro's number for no reason. They must have had a reason. They wouldn't just... That's not the reason for... well, they had the reason for doing it, but they must have had the reason for keeping it, right? They wouldn't just keep it for no reason. They wouldn't just keep it out of tradition. No, this is science. They wouldn't do that, would they? Ah. Yeah. Animation. Right. That's what we're doing. Right, that's right. Oh. Okay. It's fine. It's fine. It's fine. It's fine. Okay. Right here, we're just going to... Why does it have so many keyframes actually? What are these keyframes? These keyframes seem kind of useless. What are they for? Whose keyframes are those? Whose keyframes am I saying? No one's. Cool. That was just... I'm just crazy. Crazy. I was crazy once. Look, have you ever heard of R divided by NA constant? No. I've never heard of it, honestly. Make it and making it an Avogadro. I mean, that just... no. Dave wasn't taking it of Avogadro. This is my, like, favorite rant. Of all of my different rants, this is probably the best. Okay, hold on, let me just... And right here, we're gonna have the camera even really close in, like really close, uncomfortably close, some may say. Like that, and like that, and like this. Divided by N is the Boltzmann constant. Oh, that's the Boltzmann. Okay, then I do know that one. Is that really how it's noted down? Wait, what? I thought... Whoops, I turned off the music. That's on me. That is on me. Boltzmann constant. No, it's K, yeah. I've just never seen it in relation to the malls. I don't like malls. I don't like malls. The big mall trying to brainwash us. There we go. We're back. Yeah. Okay. I didn't see Susie. What do you mean ghost? Susie isn't a ghost. long time since she was on stream. Really doesn't really she's not my girlfriend. Gee, don't make it weird. She's not my girlfriend. It's Susie. So what should we use to make a placeholder of constant? K. Sorry, G. I'm ahead of a constant 5, 6, 7 to 10, -8. Such a perfect constant 5, 6, 7, 8. That's pretty satisfying. Susie, remember him if yours, but his monkey. I'm not. She's not my girlfriend. What are you talking about? Don't spread that sort of misinformation. You won't think I fuck a mannequin, huh? Susie is my assistant. My lab assistant. I drink because I think of the malls. The mall brings back bad memories. Ayo, make it and you help. I sent you a thumbnail for Discord. Is it good? Hold on, let me check. I'm not good with thumbnails. I'm not good with checking thumbnails. Yes. Hold on, you send it. I have a lot of people messaging me because most of them are bots actually. Physics Universe. What's your name in? What's your name on Discord? Jürgen, I see. Listen, I'm not good with checking thumbnails. I mean, it seems fine, I think, but I'm not the kind of guy that does YouTube thumbnails. I just use frames from the video most of the time. There we go. Pop that in. We have Discord? What's the server? Yeah, I have Discord. Link is in the description. Do y'all really skip all of the ad segments? In every single video, I mentioned I have a Patreon, I have a Discord server. I mentioned that I mentioned all these things, and then do y'all really skip the ad segments? That hurts. That really just hurts. I never skipped make it. I know you'd never skip it. Happy. Really thank you so much. There's another video on Gundam physics. It gets low, but it was really amazing. Best intro calculus I've ever seen. I'm really glad you say that. I honestly don't think that video was all that great. I mean, it was good, but it wasn't really 100 times better than every other video on YouTube. So yeah, that video was decent, but I should really make a better one. Hold on, it's almost there. And right here's where the animation will end. So right here's what we need. Is this going back? And then it moving up. Like this. And then, oh, that's pretty nice looking scene. What's your favorite video you've made? It's a toss-up between the explaining chemistry for electricity, I really like that video, or worst mistake you could ever make. Either one. If I hop in VC, listen! Hop in! That's what you have access for. I need to know. I need to know why Avogadro. I need to know. Hold on, let me do that. Oh, hold on. There. I'll say something. I don't think anyone can hear you because I set up differently. Technical difficulties, just almost practically. It's what do you mean you're not capturing? How are you capturing Discord? Not capturing Discord. How about now?
Hello.
There we go. Oh, I'm a professional.
Nice.
Behind the flame. That's everyone. That's flame. I need
Hello.
to know. I need answers. Why is Avogadro?
I mean, so basically, I was looking at like my notes and stuff, and I think the only conclusion I could come to is that generally, like when we make a constant, we have to like base it in reality, right? So we can't just pick an arbitrary round number. I think that's literally it. It's like if he'd proposed this constant and they were like, okay, what's this constant based on? And he was like, oh, nothing. It's just it's like it's about the the right order of magnitude. Then people would have been like, what are you doing? So I think that's it, but I don't know.
But there's a
Yeah,
fix.
I know, I know.
No, hold on now. Okay.
Oh, are you gonna come up with like 5 constants that are just not based in reality at all?
Well, Avogadro constant. Yeah, I'm maybe wrong. Yeah, this is this. Define the number of constituent particles using molecular spirals per mole and just normalization factor. Yeah, but how is it defined? First measurement, SI definition.
I mean, it's defined as the number of atoms of carbon to make 12 grams of carbon 12, the isotope.
Okay, why are we picking 12 grams then?
12 because it's carbon 12. Like the mass of carbon is it's 12 protons and neutrons.
Okay, but what if we picked 24 grams? It would still be
I don't know.
just as based in reality.
I don't know.
The multiplication factor of 1, it really seems quite arbitrary to me.
This has actually baffled me
It's so...
because I never thought about it.
Yeah, it's dumb. Oh, you're getting me started. Don't get me right up on the mall again. So, let me get this straight. In the year of our Lord, 18...
Well, I mean, okay, no, okay, but
11.
if you think about it, like carbon 12, okay, is 12 grams, and so we've picked that, and so it's like, yeah, you can just, I don't know, yeah.
Hold on, so you all mean to tell me that in the year of our Lord,
Like, why is it not divided?
1865, some random guy was like, hey, this specific atom, actually, this many of this specific atom is equal to this mass, let's make it a constant. And ever since then, for the past 2 centuries, no one was like, hey, why not a
Well, that's the
different
thing,
atom?
like, it's too late to change it now.
Why
Because,
not-
like, everything's based on it.
Yeah, so that's the reason for this 2 centuries. No one was like, "Hey, why not a different
Yeah, I
atom?"
mean, yeah, he picked this,
different
and then everyone started doing science with it, and now we can't go back because we'd have to rewrite everything.
I am heartbroken. Oh no, I am.
But, I mean, yeah, the constant is for 1/12 of the mass of carbon 12, so it's like it's meant to
That is
be
so
roughly
arbitrary.
equivalent to like 1 gram.
That's
But yeah,
that's kind of like us. Oh, that is so annoyingly arbitrary.
and I guess he picked carbon because carbon's like the most relevant atom.
Oh. Oh no. When I started doing the mole bit, yeah, I started doing it as a joke. I was like, oh, I don't like the moles. I think they're pointless. They're constant on the unit. But this is dumb. Like,
I mean, it's all just to help with stuff, It's all for
yeah, but
convenience.
when you compare it to, yeah, I mean, you have stuff that's fine. But when you compare it to other base SI units, you have stuff like the meter, for example.
Yeah.
And just because the speed of light, and so in this case, like imagine if we did the meter the same way. So, how am I even gonna? Oh, I don't even have a good analogy for this. I really don't. This is just so completely awful. I don't even have a good analogy.
I mean, yeah, it's like if farmers with their dozens started like doing all their like tax stuff based on dozens, or I don't know, I don't even know. Like that.
Yeah, it's not really as if they
equivalent,
started
but,
doing their tax stuff based on
yeah.
dozens. It's more like if they started doing their tax stuff based on 11.78926521, right? If they did it based on dozens, I wouldn't be quite as mad. But if they started doing it on a freaking constant with 17 decimal points, then Yeah, I'd get pretty upset.
Like, like they had like 12 eggs, and then they divided the mass by 12, and then set that as as a standard for all the eggs.
Like, imagine that's so fun. Oh, I was really honestly kind of hoping that there was a reason to it, but it's.
No, I mean maybe there is, but I think it's just like it was picked and we rolled with it.
I mean, it seems like, to me at least, it seems like the atom, the amount of atoms, and the corresponding weight are all, well, corresponding mass are all arbitrary and just a random pick. Well, not random, there's only some reason,
Yeah.
but it really doesn't feel like something that, you know, like, for example, we could define it as the amount of well, we would have to do it on an atom, so wait, molar mass of hydrogen. What's molar mass of hydrogen? Oh, and
be
by the
very
way,
close to
molar
one.
mass of hydrogen is 1.
Yeah, because the atoms aren't all, they're not all balanced properly. That's the issue.
It's so we could just do, we could have just done it based on the molar mass of hydrogen, and I don't know,
Yeah.
we could
We
define
could
it,
have, and it would have been slightly different, and it wouldn't have affected anything.
yeah, and we could have also defined it as like the amount of particles that make up that amount of hydrogen atoms that that have a combined mass of 1.007947 grams. And then what would be
I mean,
really
yeah,
nice about it is that you wouldn't have to use a freaking constant with 17 different, I don't know, 17, wait, it's not 17, some different amount of digits. But you wouldn't have to use just a random number of some digits. You could just use 10 to the 24th power. That's it.
Yeah.
Add a yocta or remove a yocto.
I mean, to be fair, like practically when we do it, we only do it to like 3 decimal places, like 6.00022.
Yeah, or you could
So
just,
it's not-
not do it with
Yeah,
any decimal
yeah.
places. I am so upset about that, actually. Oh, this is... Oh, chemistry, I'm disappointed now. Well, not really chemistry, I'm disappointed with base AI, SI. I need to see base SI units. What was the reasoning? What? Give me a reason. Why?
I know you see all these useful ones in here, like meters and kilograms.
Yeah,
and it's just
meters.
moles.
Kilograms, they're phenomenal. Second, that's all of this is phenomenal. The candela I don't really see used that often, but I get it. Kelvin and ampere, also fine. I mean, ampere is also not, well, I feel like ampere could also be defined in relation to like a, round number of elementary charge. I feel like we could have done it, might as well. It wouldn't be that difficult. I mean, can you imagine how easy it would be to, like, I don't know, calculate electrolysis reactions if both ampere or coulomb and mole were defined based on like round numbers? Because then you could just do the reaction. You would just do the reaction with the exact number
Yeah.
of electrons, exact number of this molecule,
I mean,
exact number of
I
this
think the
molecule.
thought when coming up with it was that like you don't usually have to convert from mol. Like it's not a a frequent conversion you have to do. It's only used in like some certain cases, right?
Yeah, don't worry, guys.
And so the idea was like
Okay.
he could just define it in terms of the number of molecules, and then it makes everything easier.
So I just want to know, I'm not making fun of you right now. I'm making fun of them all, but like this would basically be them saying like, yeah, guys, you know what? We know that our system is garbage, but don't worry, it's also kind of useless. So won't be that big of a problem.
I think it's useful as a unit. I just think I do agree that like he could have picked a nicer number.
I
But in
think
the end, like it was based on something, and it's not too bad. Like you can just use it.
I think personally, it's my own goal to do all of my chemistry and go through my entire chemistry period at once using them all. And as an additional challenge, I'll also avoid the Avogadro's number as much as possible. I don't care everyone else uses it. I will single-handedly strong-arm the science community to move away from them all. This is my arch nemesis.
Well, the thing is, we have to use it for like certain things, and so you'd have to be convincing people to use a different number, not just to not use it.
Well, yeah, but to be fair, the different number, I mean, it's not just any different number, it's just such an objectively better option.
Yeah.
Because with this, that's kind of the point of prefixes, right? The point of prefix is that we don't say a million meters, we say a megameter.
Yeah.
And so if you remove the Avogadro's constant, then you can just say yoctograms and grams. You don't need any numbers.
Yeah.
But I don't know, I'm just crazy. I mean, I do like me not being able to calculate anything without a freaking... I'm pissed. I'm so... I can't do this sober. I need a drink. Chemistry, look. You gosh down chemist using SI-based units. Look what you make me do. I think C12 was picked because the new unit was defined the basis. Yes. Yeah, but the... I think like the atomic mass unit is... I would give the atomic mass unit a pass. I think that's a solid one actually. I feel like we could do it a bit better, where like we would define the grams better based on the atomic mass unit, but that's a topic for another conversation. Make it rich right now. One of them make it 7 years on stream. No, it's not. I actually enjoy having other people over on stream. Lamppost, you're giving me... I'm scared. I'm terrified.
I would still teach him if he was a worm.
I mean, I would, but boy, I'm getting kind of spooked. I am gay for make it. Well, y'all don't even know my sexuality. You're just assuming. Just, I'm happy saying that I'm with Susie. That's so mean. Just because I have a mannequin doesn't make me weird, does it? Who doesn't have a mannequin sitting in the corner of the room?
Yeah, surely.
Where they like
yeah.
chat with them when they're alone, talk about science stuff. I mean, I
everyone
don't.
does
I don't.
that.
I'm talking about a hypothetical scenario, like, you know, like if someone had. The weather's been crazy recently, right? It's wild. It's so rain and stuff.
Yeah, it was hot and then it was raining.
Yeah.
Yeah.
As speaking of chemistry, the SI base unit is said mutually. I love Wikipedia, by the way. It's like the SI base units form a set of mutually independent dimensions as required by dimensional analysis, commonly employed in science and technology. Citation needed.
Yeah.
You didn't provide your sources for why it's commonly employed in science and technology. Because I've never heard of base
Wow, how are
SI
we meant to
units.
believe him? Yeah.
Yeah. Honestly, I've spent so many hours looking at it, but I haven't, like, if I just found... I'm trying to make as many puns as possible, but these assignments are not actually easy for it. Like, I spent hours looking for uses of base SI units, and honestly, I was expecting like a ton of it to be there, right? But
Yeah.
after looking for miles, I couldn't find anything. That's about...
Yeah, that's the thing, because when you were asking, like, why was it this number? I was like, oh, there's probably a really obvious reason that I've just forgotten. So I started
Yeah.
looking, and I was
I
like,
feel
hang
like
on.
it's just you know it's just basically you know, everyone there is everyone using moles is like, oh yeah, I don't know the reason, but there has to be a reason, right? We wouldn't use this absolutely random number for no reason, right? I feel like that's just what's happening.
Yeah.
Everyone is expecting there to be a reason. We're just... Oh, damn it. I was really happy with base SI system, but now that I'm looking at it, it looks just more and more awful. We could just define these things better. So, for example, Kilograms. Oh, that's another good one actually. Oh, let's take a drop of one of the big boys. Kilograms. Atomic mass unit. We could define in relation to the atomic mass unit, because as you see, it's pretty awful. One atomic mass unit is like 1.660539 and something. How is currently how are the kilograms defined? I think there was something. Timeline, name, terminology, redefinition. Yes, it was based on Planck's constant. Oh, okay, that's actually a pretty good one. Never mind. Okay, this graph.
Oh my god.
I love how
Yeah, I
you
know.
have this graph. And the mole
I've
is
seen
still-
these diagrams, and it's like mole isn't connected to
The
anything.
mole is just there on the side chilling. Like, yeah, guys, I'm totally base SI unit, okay? I don't contribute anything, but I'm here, okay? Oh. What's also quite bizarre for me is that voltage is not a base SI unit. That's kind of weird, in my opinion. I get the conversion, but it really feels
yeah.
like voltage should be a base SI unit.
There's a nicer diagram.
No, it's just, I love these diagrams because they're always so massive.
There's this diagram that's all like it's all curly arrows.
Is it like, hold on, a diagram?
If you search SI units diagram, it's like the first result.
Hold on, SI units diagram. Oh, this one, yeah. Like, that's what we want. And also radian is there. Which, I mean, radian would be better than mole, but that's a side thing. If you're talking about constants which are trying to, well, if you're talking about not units which are mimicking a unit, radian is just better than mole. But that's a topic for a whole different conversation. There's a lot of messages. Alright. Lamppost, you might not, because you're making me really uncomfortable right now. Best constant. I love this I love how we're completely in control when it comes to constants. It's a convention. We basically set it to whatever we want it to be, and then we use it, and we still just choose the worst possible option every single time. Make it the straightest, gayest, helicopterist thing to be attracted to.
What?
That's a sentence. I think that's one of the sentences of all time, certainly. Well, how are you enjoying yourself, Flame, here today?
I'm good. I'm chilling. I studied for like 6 hours today, and I'm just bored out of my mind.
Oh yeah, I am. Why is Kelvin disconnected? Oh, that's an awful diagram.
Well, I mean, none of them come from each other, so it's just a case.
Yeah,
of,
but
there are some relationships.
I mean, none of them come from each other, but you need some constants to define others. So right here, for example, like you can't define the meter without seconds, because meter is defined based on the speed of light, and in order to get the length from the speed of light, you need time to be defined. That's why time is the starting point.
Is it? I thought the meter was defined from something else.
No, it's speed of light. I really like it actually. So seconds are the cesium, meter is speed of light, then mass. I don't remember. I did just recheck it. What was mass based on? Oh, Planck's, right. Planck's, now I remember. Oh, age, that's right. So basically, almost everything is based on time.
Yeah.
So mole is completely unrelated because we just picked the number for no reason.
Well, I mean, the mole comes from mass, in a way. Like, it's a number we picked based on a mass.
No, because the difference is that, like, with speed of light, for example, it is like a real thing you can find, right? So
Yeah, that's true.
you have
Yeah,
speed
it's a
of light,
physics thing.
and it's unchanging. No matter who comes up with the idea that speed of light should be the constant, it will be the constant. But for the mole, it's more like, oh yeah, I think 5 should be a constant. And then everyone just accepting that, when you can also say that 4 should be a constant, and 2 should be a constant, and maybe 7 should be a constant. Which is different from the speed of light, because for the speed of light, if you have two people and one person says, I think speed of light should be the constant, the other person says, I think 5 meters per second should be a constant, then the speed of light wins because of the relativity. So 5 meters per second is different based on from what point you're observing it. But the speed of light is always constant, no matter who's observing it. That's why it's better.
Well, I don't know, because I feel like
for seconds is
like
a bit...
picking the speed of light is like picking the mass of carbon, right? Like they're two physical things you can measure.
No, but that's actually really cool, because this is different. Oh, and I love the speed of light. So here's the difference.
Are you going to talk about relativity with mass?
Absolutely, yes. So
oh, here we go.
So velocity.
I haven't looked at relativity in a while.
Oh, I mean, relativity is phenomenal. So you have, so let's say that you define meter based on 5 seconds, for example, for 5 meters per second, right? So you have object A, which is going forward with 5 meters per second, and that defines your meter. But for someone who's moving at 2 meters per second,
I know this. I know the speed that.
Yeah, it will be different.
I know where like why the speed of light is.
Precisely, but that's something that you don't get with anything else than speed of light. That's why it's a constant. But for a mole, if you have mole defined as Avogadro's number based on carbon, right? Something that's carbon 12 amount of 12 grams, then it's just as good as any other number. You can say, okay, but why not pick 1,000 hydrogen? Why not pick 1,000?
Can't you then say that, like, why not pick, like, couldn't someone have defined a meter as like, I don't know, a foot instead? Like if we adopted like feet, for example, and rolled with that, and it did everything based on feet as a unit, we would still have it defined based on the speed of light, but it would have just been a different value.
Yes, yeah, and that would be fine. Yeah, but the thing is, but my problem here is that right here it would be still defining the speed of light. So let's say that. I don't know. Would be a good example. So yeah, it still works as a unit, as in you can still measure that amount. That is true. But to be fair, measuring that amount is not difficult since it's a fucking integer. So why would we need to define it in relation to anything? The whole point right here is that if we ever lose our reference, right? If we ever lose every single measuring device on Earth, then based on this definition, we could still recreate a perfect meter. Even if we lose absolutely it all we need is just a number. But right here,
we still need seconds to get the meter back.
Precisely.
Right,
you just shine light and in vacuum check the time.
Yeah.
But here,
we still need seconds. But yeah, okay.
But right here, we wouldn't need an experiment. Even if we lose all references, we still have the number, and the number is itself. There is no like deformation. It's an integer.
Okay. Yeah. I get what you mean. Like.
Yeah. So that's the whole point of defining the units so rigorously. Even if we lose every single reference on Earth, we can still recreate them. But for them all, it's a number. We would never need to recreate that. We just need to remember the number. And so then,
I mean, we could recreate it from the mass.
Yes, but
yeah,
it's just a matter of remembering number. You don't. So why pick something that's easily recreatable when there will be when you'll never have a need to recreate it? So you basically need something physical and a constant in order for something to be a unit. But for the mole, it's just the constant. There's nothing physical. There's nothing physical required. If, for example, all of a sudden, carbon stopped existing in our whole universe, right? Just quantum probability. Wednesdays, am I right? Carbon doesn't exist anymore.
They just all collapse.
They just all collapse. They all disappear. We would still have moles, and that's because you don't need the carbon to check the moles.
Yeah, okay, I get what you mean. Like
Yeah.
it's not tied to any other units in a way.
Yeah, it's like it's
Like
just
because the mole is a value, whereas a meter isn't a value. It's a unit.
precisely it's a unit, not a constant.
Yeah.
Oh, I'm just slowly but surely turning people into my church of make it to open their eyes.
I mean, no, like I agree with you on the main thing.
Yeah, moles are. I don't know. The first reaction I always get is like, "Oh no, I use moles all the time," and like that's actually precisely my problem. If people didn't use the moles, it would be a much easier sell.
Yeah.
If we didn't use the moles, then that's actually an impressive amount of time to rant about the moles. Honestly, that's an impressive.
We should just move on, I think.
Yeah, that's really impressive. You have to stop me whenever I get going on these topics.
Yeah,
Okay.
okay. All right,
Just
I'll stop you.
I
Yeah.
know. Safe word for not ranting
No,
about the
what are you
moles.
doing in this 3D bit? Is this the intro?
Oh, this is the intro. Yeah, you actually have the access. to
So is this an
scripts, I think.
electron moving through a wire, or?
Oh damn it! Now we're spoiling it for people.
Well, no, I didn't know. Like I can see a sigma orbital up there. You know, like.
But yeah, it is.
I don't know. I saw a sphere and I saw a wire with some light going through it. Like.
Yeah, it is. That to be yeah, as I mentioned, people can figure out what this video will be about based on context clues by themselves. But for this video, have you seen the What is Math video? You can say no. I
I'm not
won't blame you.
sure. I've watched like bits of all your videos,
There we
but
go.
I tend to like
See-
watch
you
them
see,
when
I
I'm in
don't-
bed, so I like
It's
fall
it's
asleep
fine. It's
watching them.
fine. You don't have to watch. It's fine. I suppose it is a very awkward question to ask. I get why people would be awkward.
I
but,
watched
like,
the whole chemistry one because I was like curious to see how you convey it.
honestly, it is a pretty awkward spot to be in when like I just ask someone point blank, have you seen this video? Most of the time, the answer is gonna be no. I mean,
No,
we can
I've
see.
seen. I have seen bits of like almost all your
I don't.
videos.
It's
so.
fine. You don't have to explain yourself. It's fine. The point is, for the What is Math video, the entire thing was like 3D animated, and it was like a singular, continuous animation, which goes like this, and everything is moving the entire 8 minutes.
When was this one released?
3 weeks ago.
3 weeks ago. Okay.
Yeah, it was the right before the chemistry one. But so for this video, I'm the same thing, except this one will be around 16 minutes, I think. I think that's good. So the whole thing
Okay.
will be just one continuous,
Yeah.
massive animation. Just explain. Well, not continuous, but you'll see what I mean soon. Yeah, I'm really excited for this one because normally when I say that I'm gonna make a video, I just like note it down in my list of videos to make, and then maybe write a bit of script. But for this one, I'm starting right away. That's how I know
That's
I'm
good.
serious. That's how I know I'm invested. There we go. Oh yeah, this is gonna take years to render. Oh yeah, video will be done in May 2027. Sick. Oh, another question. Or maybe you'll be able to help me. I mean, I'm guessing honestly, it's I don't really know who would be able to help me with this, but do you know what I could do with sulfur?
Sulfur.
Yeah, it's an odd question. I know, sulfur. Just anything useful with sulfur.
I mean, what did? As in, like, you just want to do something interesting with the atom?
Yeah, I'm not saying that like, it's I'm not saying that I may have bought a couple kilograms of sulfur with no.
Oh,
clue to
you
what
mean
to do
like
with it.
physically something interesting
Yeah,
with sulfur?
yeah, some reaction,
Okay,
something.
okay.
So
Oh.
I'm not saying I bought a couple kilograms of sulfur with no plan, no deeper plan. I'm just saying that like, if I did,
I did a couple experiments with sulfur in my first year.
oh,
I remember because one of the things you have to be careful of with a lot of sulfur reactions is you make sulfur dioxide, which is toxic.
and then yeah, that's precisely my issue.
we were doing these reactions in the fume cupboards, right? Because the sulfur dioxide gas is toxic. And I looked over, one of my friends was doing his reaction on the desk in front of the fume cupboard. And I was like, you know, it's making toxic gas, right? And he was like, what? So he
That's
rushed it into the. Oh
that's
man.
probably
Oh
one of the last things you want to hear, like when you're doing a reaction to something like, "Oh, you know it's toxic, right?"
yeah. That was the whole first year chemistry. Like no one knew what was going on. They were just doing stuff, and they were endangering everyone else in the process because we were all next to each other. I'll have a look and see what reactions I
Because
actually
yeah,
did.
I mean, the obvious one everyone keeps recommending, and yeah, I know why. It's sulfuric acid, but that requires
Yeah.
sulfur trioxide. And I don't want that. I don't have the equipment for that sort of thing. So preferably nothing with sulfur trioxide. I feel like dioxide I could deal, but make it. What's your PC specs? RTX 360 and then AMD processor and then something else I don't remember. Alright, so right would be this. There we go. Yeah, I really don't know what to do. I'm not joking by the way. I bought literal kilograms of this stuff. I don't want to throw it away. To be fair, I should have come up with a plan before I bought it, but
Oh, here's an experiment that used actual sulfur, like just sulfur by itself. What did we do?
there you go. Animation finished. That was
Yeah, this is the one that made sulfuric acid. Uh,
what are you doing? I'm animating something 3D. That's precisely what I'm doing. Is there a perfect odd number? I don't know what you mean by perfect. It's actually quite impressive the fact that I spent most of the stream ranting about the mall. The animation is just a side thing. Animation is just in the background, you know. Oh, it does look good.
okay, this reaction, we did combustion of sulfur, which made the sulfur dioxide, which we dissolved in water. We measured the pH of the solution. And then took the sulfur solution and used it as a reducing agent in... Oh, we reduced iodine to iodide using the sulfur dioxide.
Wait, doesn't that make sulfurous acid? Because I think there's sulfuric acid.
I'm not sure. It doesn't say. It doesn't say the actual reaction. Oh, and there's also one about allotropes of sulfur.
I would know.
Allotropes are like. Let me get the definition.
Make it okay to learn new skills. Yeah, I'm so glad I finally learned how to freeze.
They're like the different ways for a pure element to exist naturally. So you know, like carbon can come as like graphite or diamond or whatever. Like,
Oh, okay.
you have that with sulfur as well.
Oh, that's okay. Tropes. That should have actually. The opes, it's like isotopes or
Yeah.
well isomers.
But I guess for this you would need to like actually buy the different allotropes. So I assume you've just got like pure normal sulfur.
Yeah. It's fine. It's
yellow
on like
sulfur,
2
right?
kilograms. I can just
Yeah.
keep it in my cupboard.
Yeah, I mean you can burn it and dissolve it in water, and then you get your sulfur. You then. I'm confused because it's like. It says you take the sulfur dioxide solution and you add it to diluted iodine. You do it drop by drop until the brown color disappears.
Hey,
It's iodine and potassium iodide.
hi, the comment, hi, I'm following recently and want to know how a man could be that good in physics, chemistry, math, tech, etc. Are you ridiculously smart? No, I just pretend. That's actually my secret. I would recommend. Really easy. I mean, all these things aren't that difficult. I don't talk about anything. I don't really talk about the specialized things. So, for example, I talk about the general stuff. So, for example, if Flame was here streaming instead of
Hello.
me, then you get a much more like an in-depth explanation of the things which I just hint at, you know. But since I'm here streaming, we're just doing free animations.
Should I just send you a picture of this experiment and you can read it?
Yep. Also, Happy just said, I remember he once cyanide poisoned himself just to make cool looking glasses. How did you know about that, by the way? I did cyanide poison myself a bit, not too much. To be fair, I don't know exactly what cyanide poisoning looks like. But I do know what it feels like. Have you all ever, like, chopped spicy peppers and then rubbed them into your own eyes?
Yes.
Well, that's...
I've done a lot worse than eyes.
Well, well then...
Because I use chili for like all my meals.
Well, then let me tell you. Making a mask and gluing it together with cyanide right before you have to keep it on for like half an hour. It's not good. It's not a good idea. It burns a lot. Maybe that's how we can learn faster.
Okay, I sent you the. It's like a 3-part experiment. So the first one is making sulfur dioxide, and then it's using it as a reducing agent, and then it's using it as an oxidant.
That's reducing an oxidant. That's versatile.
Yep. I think there's another one in here as well. If you decide to do any of these, let me send you the safety stuff as well.
SO3 negative.
Yeah.
SO3 to my. That sounds terrifying.
Well, SO2 is already toxic. So.
Yeah, SO3 is that's lethal. And I'm not. That's not even me making a hyperbole. Inhalation may be fatal if inhaled. That's not even a hyperbole. Oh, this is genuinely making sulfuric acid.
Yeah, I think in the end you end up with sulfuric acid. Okay, I look. None of the other experiments use just normal sulfur. They're all sulfuric acid.
Damn it! Well, I didn't spend too much money on it.
Well, I mean, this experiment you could do potentially. I mean, you'd need to buy iodine and dissolve it in potassium iodide, but yeah. It's just a very dangerous experiment. That's the thing. It's you need like a fume cupboard to do it because it produces.
Okay,
toxic
if I
gas.
do this, what do I do with the rest? With the rest 950 grams of sulfur?
Oh yeah, you also don't have disposal, do you? Oh man. Oh. Yeah, disposal is a whole other nightmare with practical chem.
I need money, everyone. Listen, I'm in a pretty awkward spot. I don't know what to tell you all. I've bought so many different chemicals, and they have to stay with me. So, also another thing, I want to make some sulfuric acid, like a lot of sulfuric acid, and the main thing holding me back is that I don't know what to do with it afterwards. That's my only problem. Only.
I mean, once you have sulfuric acid, you can then use it for like different things in chemistry.
Yeah, but when I say
a strong acid,
I want to make, I mean like, I don't know, 7 liters of sulfuric acid. That's kind of the amount. the silence.
Oh, apparently
Oh
this
my-
this reaction is catalyzed by vanadium pentoxide. You know, we were talking about vanadium complexes the other day.
Yeah, that's precisely what I got.
Yeah.
That's the only one I've seen it actually. That's the only place I've actually seen vanadium catalyst.
Vanadium's like a good catalyst for a few things.
Why did they use in Iron Man? Why did they use palladium? No, something like vanadium. It seems so much more magical.
In what?
Iron Man. They just
Oh,
arc react. Doesn't
wait,
matter.
what, for what?
Arc reacted in a Tony Stark thing in the middle of the head chest. Doesn't matter. The point is sulfur. Just I'm a nerd.
I
Okay?
have to look at. I was looking at palladium coupling reactions earlier for my studying.
I love palladium.
I can show you. I can show you some of them.
I
if
love
you want.
palladium because of the 10 electrons. That I'd read. That's just it's such a cool thing.
I can show you some study notes really briefly.
Make it cares about our safety. No, his no. He would take more precautions. I take a lot of precautions. That's why I'm not gonna make just sulfuric acid with the sulfur. Because as much as I like the idea of having a lot of sulfur trioxide just floating around my office, I don't think it would be good for me. I don't know, just a wild guess. Wait, can sulfates exist in the form of gas? It's curious. This just feels like I'm... Hey, make it. Are you a college student? No, I'm not. I'm just a random guy on the internet. You should watch Building a Weapon with Make It. That video is really old. I'm gonna make a new one soon once we get 25 patrons. Which were like 7 more months, something. Make it. How do I make explosives? Huh? Come on. I don't like this whole just liking explosives because of explosions thing. Because like, it's not what do you mean make? Why would you just go and buy gasoline if you want explosives?
Well, I don't think gasoline counts as an explosive. Explosive, they're things where it's usually like reactions that produce a massive amount of gas at once. So usually
Yeah,
lots
so
of explosive
re-reactive,
molecules
basically.
have nitrogen in them. Sorry?
Reactive, right? Oh my.
I mean, really reactive, but also produces gases from the reaction because obviously the gas has a way bigger volume than the solid.
Wait, that's actually a good question. Why nitrogen? What does nitrogen have?
Well, so nitrogen, generally in these like explosive molecules with nitrogen, you have these nitrogen atoms next to each other that would be a lot happier being just diatomic nitrogen because you know nitrogen exists as N2 gas, and so when these react, which they're usually pretty reactive because it wants to become nitrogen gas, when they react, it then produces all this nitrogen gas at once, and so it explodes.
I love how once you understand chemistry enough, you can just what molecule you need. Like you don't know if it will be stable, but
Yeah.
you can figure out what.
I don't know. I kind of suck at like remembering reactions. Actually, like, especially for a chemistry student, I'm really bad at
I don't think it's
remembering
useful.
specific reactions
Honestly,
to
remembering
things.
reactions, I don't think it's that useful.
Yeah, it's useful for my degree. So.
Okay, that's fair. That's a fair point.
I mean, it's useful as a chemist as well. Like, if you want to do something, you're like, oh, what should I use to reduce this? And then you think, oh, I can use this reducing agent.
Yeah, but
this
that's why databases exist and internet exists.
Yeah,
right? So,
yeah, that's true. Yeah.
for example, if you want to make, I don't know, so, a good example.
But it's more for like things that haven't been done, you know, for like research. That's where the issue is.
Wait, so, for example?
Well, I don't know. For example, like my research project in the summer, like my professor came up with all the reactions, and I would have never like come up with them because there's so many different ways to do it. You know, you have to be like creative to come up with it.
Oh, that's what you mean.
Yeah. Although actually, one of those reactions is Have you heard of the click reaction or like click chemistry?
No.
It was a Nobel Prize 2 years ago. These guys, they basically came up with a set of organic reactions which are really, really easy to do. Where you basically stick like an A on one molecule that you want to react, and you stick a B on another molecule that you want to react, and the A and the B parts both react really, really, really well. And so it's like if you have some thing that you want to stick to some other thing and you don't know how to do it, you just stick this A and this B on, and they both just react. And so it's called like click chemistry,
Wait,
and that's what I'm doing in
what's the
my
A and
research
B?
project. For example, the A is I think there are a few different types, but like the main one I've seen is the A is an alkyne group, and you know what alkyne is from your IUPAC, and the B is I think it's a triazide. Let me check. I get azole and azide mixed up. It's 3 nitrogens. I think it's just azide group. Yeah, it's just azide, which is 3 nitrogens kind of next to each other. And I can show you the reaction actually, because I was drawing it yesterday morning for one of my protein lectures. I'll just take a photo and send it. It's catalyzed with copper.
Make it for getting into biology, be great, become a lander. Yes, eventually I will get into biology, but in order to get into biology, I first have to finish organic chemistry and biochemistry, so it will be a bit. Make it, you should learn accounting because it will be funny. Isn't accounting just like lawyer light? Wait, can I show it on stream?
There you go. Yeah, sure.
I just want to double check.
Don't mind my terrible handwriting.
No, you haven't seen terrible handwriting. I have the toxic bias.
Oh yeah, that's because so this was in like protein chemistry, and so the point is we can use this to attach stuff to proteins, but the challenge is that to catalyze this reaction you have to use copper 1, so you can't do this with copper 1 in like in a live thing because it will just kill it. But there are other ways to get around that. Like you can use what's it called, cyclooctane, I think. So it's like a cyclooctane ring, but with an alkyne on it, and that works. That easily reacts with the azide without copper.
That's really cool.
And actually, I could explain the reason it reacts with it reacts more easily in terms of hybridization.
No, wait, let me first think first. So it reacts more easily, as in, hold on.
Okay, so the oxoalkyne will do this reaction. The cyclooctane. There we go. Cyclooctane will react more easily with the azide than just this alkyne here. And so this alkyne requires copper to do the reaction because it lowers the energy, but with the cyclooctane you don't need the copper.
And you say it's because I can figure this out.
Yeah,
so
it's in terms of orbitals. It's like it's to do with the strain.
What's really holding me back here is that cyclooctane. That's pretty big. That's pretty large.
Yeah, so it's like a ring with 1 triple bond on it, right?
Yeah.
And so you know when something's so what's the hybridization on one of the carbon atoms in the alkyne bond?
Alkyne. That's Y and E. Hold on. So that would be sp2.
No.
No.
It's what I've drawn here on the top left. That's an alkyne. The triple bond there.
Oh. Wait. Triple bond. think so. Hold on, give me a second. I'm not connecting things well. I can. No, SP3.
Nope.
Okay, close. And by close I mean another one down. Okay, okay. Which bonds? That's you know, maybe don't give me a second. Maybe just tell me.
Yeah. Okay. Well, I'll work you through it. Right. There are
Yeah.
two approaches. So one approach is, um, one approach is how many p like free p orbitals is the carbon using for the triple bond.
So it's using. Well, for the true for the triple bond, isn't it using freedom? Or is it
Well, so it's doing so. Okay, in a triple bond, what bonds do you have? Like in a triple bond?
pi sigma pi?
Yeah. And
Oh,
what
so
forms?
it's using two p
Yep.
bonds and one sigma. I mean, it's using one 2p orbitals, one s.
Yeah, one SP because
One
we've
sp is
hybridized the S.
hybridized.
Yeah. So it's SP hybridized, and another way to think about it is the carbon is bonded to two things. So using the rules of like sp3 is for 4 bonds, sp2 is for 3 bonds, and sp is for 2 bonds, or two things is bonded to. Sorry. Um, that's another way of doing it. But like you have your sp, and you've got two sp orbitals because one is going to the other carbon and the other one's going off to the left to the other thing. And then you've got two more p orbitals, and they're both involved in the triple bond because you've got two pi pi bonds. So when you hybridize, a hybridized orbital is always doing a sigma bond in the case of carbon.
Okay, makes sense because I mean, graphically makes sense. I don't know how to explain it.
Yeah.
Just graphically probably makes sense.
Yeah, yeah. Okay, so then when we get to cyclooctane, so if you think when something's sp hybridized, the two hybrid orbitals are but they're pointing in opposite directions, right?
Mhm.
But if you look at cyclooctane, they can't point exactly in opposite directions because it's a ring.
Yes.
And so you're actually kind of bending
There's
the orbitals,
an
which
angle.
it doesn't like. Yeah, because there's more of an angle on it, and so you're going against the angle that the carbon wants to be in, and so that puts strain on the alkyne group. It weakens it because you're not obeying its symmetry perfectly, and by weakening it, you make it more reactive, and so you don't need the copper catalyst.
Okay. Uh, so okay, I think I get it step by step.
Yeah.
So it's basically so it's basically less stable, kind of. Well, no.
Yeah, it's less
Yeah,
stable.
it is okay.
Yeah.
So it's less stable, thus more reactive, thus you don't need copper catalyst because it's more reactive.
Yeah.
Okay, that's cool. That's really cool.
So all this stuff, like it's one thing to say, oh yeah, it just uses a copper catalyst, but there's a reason, and you can work through the reason using other chemistry stuff that you've learned. Like when my professor mentioned this, he like brought it up, and all these other biochem students, they haven't really looked at orbitals, so they were just they were all just like, what is he on about? And I was answering all the questions.
Oh, that is phenomenal. Actually, that's some really. Chemistry is actually kind of cool.
Yeah, I mean everything. Everything.
I really
links
do get
together.
why you like orbitals so much.
Yeah.
Oh, make it. I was here yesterday for your other stream. Was this stream actually about? Though I just started watching. There was just these molecular diagrams and stuff on a piece of paper. Well, I suppose a little bit of a switch from yesterday gaming stream to today, talking about like talking about using cyclooctane to instead of copper because copper is toxic, and how about like and why you can use it. It's a bit of a switch. What I get overwhelmed with chemistry though is that like it makes sense, but it seems really difficult to predict. Like it all makes sense in
That's the thing I
retrospect.
struggle with. I struggle with predicting things
Yeah, because in
because
retrospect
there's
it
so
all
many different
is
things to
obvious.
consider.
But
Yeah.
but then when you try to predict, you're like, okay, but why wouldn't it go the other way? Why wouldn't it behave in a different way? And there are reasons for why it
Yeah,
would.
that's the thing. Because I find it really easy to explain things, like work backwards, but really hard to predict things. And I guess that's the point of experiments is we predict stuff, and
I feel like
some stuff we're like 99% certain it's gonna work, but other stuff is like we don't actually know if it's gonna work, and so we predict it's gonna work based on the theory, and then we do an experiment, and then we publish a paper. So that's the whole point of research.
honestly, I feel like chemistry might be sneaking its way into one of my favorite science fields, honestly. Because,
I
for
feel like
example,
lots of people just miss out on how fun chemistry actually is
yeah,
because they see all these like reactions and things and like, oh, I don't want to memorize all that. But here I haven't even memorized them. Like I've just kind of skipped that bit.
yeah, the
I've
whole
gone into
point.
understanding stuff.
If you have to
Yeah.
memorize it, that then it means you're not gonna be a great chemist. If you have to memorize it, and that's like a general rule in all of science, right? If you have to memorize something that you won't really be great at, then you're not really understanding it too well. How are you gonna do that if you all you know is just how to memorize already existing one?
Yeah. And I mean, I got a C in chemistry at school for my A levels because I just didn't I like didn't memorize stuff. I thought it was a bit of a waste of time. And then I went to uni. I like snuck my way into the chemistry, and it was all just being taught from scratch basically from these fundamentals with hybridization all that. And I just found it so interesting. Like it all just made sense.
I really feel like it should be taught this way. I mean,
I
in
think it's
my
just too
opinion,
complicated to go into detail in school. I think that's why they don't do it.
in my opinion, it should be physics, then hybridization, and only then models. As in, you
Yeah.
should be able to understand that people should know that hybridization happens before they even know why it's weird.
I mean, I think hybridization isn't relevant for any basic chemistry though. Like at
Yeah,
school,
but
it wasn't mentioned.
it's like, in my opinion, important that people wouldn't be weirded out by hybridization before they start learning models. Because if you go the other
Yeah.
way, if you start with models, then hybridization is gonna be like, oh, remember these models we have? Yeah, throw that out the window because all of a sudden these orbitals just
Yeah.
hybridize, they just join together. Well, you know the rules for the s orbital, you know the rules for the p orbital. Now let's just include an sp. And
Yeah.
and so I think that's the problem. I think like if people understood that like electrons don't have these simple rules in them, actually, crazy thing, but electrons are actually actual elementary particles, then it would be easier for them to understand that models are just models.
Yeah. I mean, we talked in DMs, but like I think your approach is quite a good one.
I don't know. We'll see.
We'll see.
I don't know if it's a good one. I'm hoping it's a good one. We'll see how many people get confused by the video, and then we'll have an answer. Well, this is really this is fun. I should read more chemistry. I don't want to. I already can't accept it that I won't have like an actual scientific contribution because I don't want to. I really don't want to specialize. And it's really
Well, I mean,
hard.
educating people is a scientific contribution.
Yeah,
and we get
that's
them
but that's
interested.
like the least I can do at this point. I just accepted that I am a generalist and I won't specialize, and without specializing, it is borderline impossible to actually invent something.
Yeah.
So, but hey, at least I'll get other people hooked in. I guide others to the treasure I cannot possess. Coaches don't play. I don't know what to tell you.
I mean, that's the whole point of teaching, right? It's like, you get people interested, you lead them into it.
Yeah, and then I can actually have like a piece of like if someone watches my video, gets interested in quantum mechanics, and then wins a Nobel Prize, then I can
So you're saying I should credit you in some papers?
no, what? I mean, you said it, not me. I'm just here, just just saying.
My
kind
name
of
is going to
rude
be
of
on
me
a
not
couple
to.
papers in a few years, actually, based on the research I'm doing. So that's a cool thing to
That is
look
also
forward
really
to.
cool. I really want to make videos about. I really want to have like a series. I mean, I guess it already exists on YouTube. 5-minute papers. I think is what they're called.
Oh
But I
yeah.
always wanted to have like a
Wait,
series of
that's the
videos.
AI guy, and he mostly does like AI papers, right?
Yeah, he mostly does it. Yeah, but I really wanted to have like one where it would basically be like 3 minute video about the paper each time. And it's
Oh,
obviously
that's
not
really
going in
good.
depth because if you want to go in depth, then why would you need the video? Just read the paper.
Yeah.
It's kind of the point. But like a
I mean, I don't know. I watch a lot of videos on like Nobel prizes that come up. Like whenever a Nobel prize comes up, all the science YouTubers post about those Nobel prizes, and so I watch those, and those are quite good because it's like you don't want to go and read a whole paper half the time,
yeah,
especially if
it's
it's
also
like
like
if it's like a
bleeding
physics Nobel
edge.
prize. I don't care enough to read the paper.
Yeah, it's also if it's Nobel Prize, it's always gonna be bleeding edge.
Yeah,
That's kind of what Nobel prizes
yeah,
are, right? It's you're always gonna get the coolest bits of science.
yeah. Do you know about quantum dots?
Quantum dots, no.
Oh, it's so cool. So, do you know what nanoparticles are in chemistry?
Nanoparticles, as in like ferrofluids, nanoparticles.
Is ferrofluid nanoparticles?
Ah, I have no clue. I'm asking.
I actually didn't know. I actually didn't know that. Oh, it is nanoparticles. Okay, what?
Oh, I'm
Yeah, I
so
guess
smart.
ferrofluid is a type of nanoparticle. It's basically you can make these. It's essentially these like big structures when you put certain elements together, or sometimes it's more than just a single element. But a frequent example is like gold nanoparticles. You basically just do a certain type of synthesis, and you end up with these spheres that are on the nanoscale rather than on the normal molecule scale. And they have different properties. Like gold nanoparticles, you end up with different colors based on the size of the nanoparticles, which I think is really cool.
That is-
And one of my professors, she can like look at when you make these, she can tell you the size that you've made because she works with them so much, which is really funny. Um, and so this discovery was it was like a type of nanoparticle that basically behaves like a I think it behaves like a single atom in terms of the quantum properties. So it's like these nanoparticles which are large scale that behave in a quantum way due to something. I don't know. I haven't looked into the detail, but it's like a leading edge of chemistry right now,
I mean, definitely, it's
which I think
basically.
is really cool.
I just. I don't know. Do something chemical. No.
Because it's like kind of larger scale quantum mechanics.
I just find myself in a bit of a predicament now where like I ain't got the money. I always I always wondered how is it possible that science equipment is so expensive because I mean it did seem advanced, but I never got the why would science be so expensive bit, right? Why would you
Yeah.
need why would you need the actual millions of dollars and stuff like these? But now I kind of get it, honestly. Like if you want to do science, it's not that expensive. If you want to do science right and accurately, then it tends to get pretty pricey pretty quick.
Yeah. Well, I mean, I can only speak for like chemistry, but I've seen and used all this different equipment that costs hundreds of thousands, and it's like, how would you do this stuff without that? Like, uh, do you know what EPR spectroscopy is?
I've heard of it. I don't remember.
It's electron paramagnetic resonance spectroscopy. Um, do you know
Electroparameters.
NMR?
MMR, the medicine thing.
NMR.
NMR.
NMR. So
Hold
like,
on, could you
yeah.
Say again what it was for? Like
Nuclear
electron-
magnetic resonance for NMR.
nuclear magnetic resonance. Well, okay, that's kind of obvious self-explanatory. Like-
Yeah. So EPR is like the same kind of thing as NMR, but you're looking at unpaired electrons, so radical molecules, and it's not really taught much in my degree, but I went into it because I like picked an experiment that did it. I gave a presentation on it on Friday, and it was like this. This whole machine is literally it generates this massive magnetic field. It's got these two massive plates on either side, and it shoots microwave radiation at your sample in the middle, and it puts this massive magnetic field on the sample, and essentially measures the absorption frequency. Not the absorption frequency. What it does is it changes the magnetic field while shooting constant microwave radiation at a specific frequency, and as you change the magnetic field, it changes these properties in the electron, which means that at a certain strength of field, it absorbs the microwave, and then you get an absorbance peak, right?
Yeah, and then you
And,
just
and yeah, but it's this like insanely high tech piece of equipment, and and the professor like he like switched it on and he was like, oh here, grab this, and I think it was like a metal, it was like a pen basically, and he told me to hold this pen in the middle between these two plates, and he turned the field on, and you could feel like the field on the thing I was holding. It was crazy. It's like really fun stuff.
I always feel awkward when because I've got none of these stories. I always feel awkward because I know what to respond. It's just really cool.
I mean, yeah, it's cool. And I had to give a presentation about the experiment on Friday.
How'd it
It went
go?
really well. I got 88% on that, so I'm actually super
That's
happy.
nice. Because I'm, what I really often find, I get interested about very like specific things, but what I always find interesting when it comes to these machines is that when people think of really expensive scientific equipment, they most of the time misunderstand like what actually causes it to be expensive, and they often imagine the really expensive things to be, I don't know, remaking laws of physics, stuff like these, right? And so when it comes to this sort of piece of
Yeah.
equipment, the reason why they're so expensive is not really because they generate a huge magnetic field of something, only because they're so precise in measuring it. And it makes sense.
Yeah.
You're measuring something really tiny, and you need to measure it with a really with something really strong. But I feel like because of and that's what we always find interesting. Like, how do you when you have to measure really changes in a really subtle changes in a really powerful magnetic field, for example. Now that's impressive.
Yeah.
Basically, when it comes to specific measurements, you need delicate pieces to measure them most of the time, and delicate things and strong forces, they don't go together too well. But I just always like how we get to the point right now where you have certain we get to, which is so insane, by the way, we do it so casually, we get to a point right now where you can create a piece of equipment and you can like be certain of the, I don't know, amount of atoms it has, which is and it's sometimes needed to know how many atoms you have
Yeah.
in a certain thing, and we just like just casually, you know, it's not like a huge breaker thing. No, oh, we just needed this piece of equipment for the Large Hadron Collider. Yeah, we actually need to be really exact. So this is exactly how many atoms there is. Just yeah, because why not? This is really
Yep.
cool. I really love science. I just love it.
I can show you a bit of my presentation if you want.
Oh, we'd
Got
love to.
the slides. Let me see if this works. Let me just check it's not going to dox me before you get the screen share on.
It's a fair thing. Check. Memorize stuff. Develop your skills and everything so much that you will be the perfect scientist. I mean, that would be the ending, I guess, but that's not something I can do. Wish I could do that sort of
I
thing.
think it's working. I think this is fine.
Alright, hold on.
Yeah.
So may I show it on stream?
Yep.
Alright, then just give me a second. There we go. EPS
I've changed my name here. Yeah.
Presentation
Didn't
by
have that when I
Flame.
presented it, but so I'm not gonna like go through the whole presentation in presentation format, but we use. So I said for something to be like active in EPR, it has to have an unpaired electron. So it's like a radical up here.
Yeah.
Can you see my mouse? Is that fine?
Yes.
Yeah. So we use this, and it does this equilibrium basically. And I talked about the background. This is some protein background. You can like tag EPR active stuff onto proteins, which is cool. And so basically what I had was I was given like a mystery sample and told to figure out what it is. and this was the one I had, but I didn't know I had this one. And we reacted it with some stuff to reduce it to this form. And we had to do it in anaerobic conditions as well. This is another annoying thing is you have to like for certain reactions they react with air, so you need to put like with this we had it's called like an argon line where you basically just flood the entire thing with argon gas so that it can't react with air. And then you had to be really careful to not like get rid of the argon or leave the lid off. And it's like this is the thing I'm talking about with the I'm gonna teach you a bit of theory. So it's like
Yep.
so you know your electron has spin plus half or spin minus half, right?
Yeah.
And this represents those two states. So normally they're the same energy, they're degenerate. But as you apply a magnetic field, so that's the x-axis, as you apply a magnetic field, these two states split in energy. And so one goes up, one goes down.
Mm-hmm.
And in this machine, you're applying a constant microwave radiation, which is at a specific frequency. And since it's at a specific frequency, it's a specific energy amount. And so as you shift the magnetic field, at a certain point, the gap in energy between the two states is exactly the same as the energy of the radiation you're putting in.
Mm-hmm.
And so when that's the same, it then absorbs the light, and it detects that it's absorbed
based on
light.
that, you can get the angle of how much it's increasing.
Yeah, it's a
I just
You
want to
can-
ask
yeah,
questions
so-
in
yeah.
advance so that to make sure that I
Yeah,
actually get it. That's what I do. It's just
yeah. I mean, it's more about So the angle is this bit here. Whoops, I clicked. Where did I go? The angle is this here.
Mhm.
So you have this G value, which does depend on the atom, but on the molecule. But for this experiment, I wasn't concerned about the G value too much. But you are right that the angle will be different when in different circumstances, and so that angle would then would change where these peaks are. But what mattered more for this is that it can split. The peak can split based on coupling to other nuclei in the molecule. And so I had, this is an example where your electron's coupling with just one nitrogen nucleus, but because the nitrogen has a L value of 1, it splits it twice, and so you end up with 3 equivalent peaks. And so, it's complex, complex diagram, but it splits it. And this is a simulation of with 2 nitrogen nuclei. It splits, if you imagine, it splits this into 3, and then it splits each of these into 3, and then you kind of add up the peaks when they overlap. And so you end up with like different intensities. And so then with mine, I tried to draw Pascal's triangle and I missed out a line on this. In mine, we look at the environments on the molecule, and we've got 6 hydrogens here, which it can couple to. And so that makes this this pattern here of basically Pascal's triangle here, because if each of them is splitting into 2 each time with the hydrogens, then as you split it 6 times, you end up with like a 1, 6, 15, 20, 15, 6, 1 intensity pattern. So that's the relative intensity of each of these peaks. And so then there was also these 2 hydrogen environments here, and you get that. And then I was talking about how you can how you'd combine them together at 2 extremes. And then this was what I actually got. This was like the data I got from my
wait.
sample.
May I guess? Wait, did you use a certain mathematical tool in here, or because there feels like there's one thing which
We did. What do you mean, like on?
yeah. This feels
No, we didn't. We didn't actually.
really.
Well, okay. We used the package that does some stuff. It fits. I'll talk about it in a minute.
Because this
So
feels
we
like
got- yeah.
the perfect. Honestly, when people ask me about where use Fourier, I always give them everyday examples. But this feels like a perfect example of
it's
how it's
probably
used in science.
using it when it simulates. So I simulated these. Like I put some values in, and it spits out these graphs. So it's probably putting that in to get stuff, and it's probably involving Fourier. But in terms of doing this, I can't really get the exact values back out. but what I can do is I can simulate a graph and fit it to this graph. And so I got this kind of these peaks, and when you count these up, this is like it looks like a nonnet, so like nine, a splitting of 9, which would indicate 8 hydrogens in the same environment. But we've also got these weird wiggles here, which aren't great. And so this was like in MATLAB, we did this whole fitting function where it was like we put in the values that I'm predicting. So I put in the the 2 hydrogen environments I think I have, and put some coupling constants. Coupling constant is like the width of these the gaps between these peaks. So when I was here, so I said one of them gives you like a septuplet and one of them gives you a triplet with these. Depending on which is a bigger coupling constant, at 2 extremes you could have a septuplet of triplets, or you could have a triplet of septuplets, right? But it's going to be somewhere in the middle where they're kind of mixed together and overlapping. And what I got was they were actually almost exactly the same coupling constant, so it ended up as a nonnet basically. And so in this, I like put in these values and told the function it can vary those values by a certain amount, put in experimental values, and then called the fitting function. And so then it fits a graph to the experimental data. But it did it kind of badly because I have these weird peaks here, which are impurities. And so then I had to go and, so these are the coupling constants, they're almost the same. So then I had to go and like manually fit it to do some stuff here to try and see if I could identify the impurity. And so then I subtracted this manual fit from the data to try and get like an impurity spectrum, but it just kind of didn't work. And so I gave up, and that was it.
That is really cool.
It was a fun experiment, and I really liked presenting it.
I feel like there's one thing which I mean, I don't know if it would actually work, but there is a possibility. You know what Fourier is, right? As you don't.
Yeah.
You do. Okay. And I'm just thinking if that could actually tell you the impurities. I'm just it's technically not wavelengths.
I don't know if you can do Fourier to identify the peak, because the main thing we're looking at is the splitting pattern, not the like there's no
wavelength.
There's no like frequencies going on. There's no periodicity in it.
I know, but that means that's what I'm thinking. I mean, if there were, then it would be obvious.
Yeah.
But that's precisely what I'm thinking, because I don't know. This is just cool. It is just cool.
I mean, the way I could have found the impurity was like speculated about what it was, and then simulated an impurity fit, and simulated that alongside the normal fit that I also simulated. But I didn't know enough MATLAB to do that, so I just didn't bother.
That is still really cool.
Yeah, I found it really cool.
It really is. Oh, that's awesome. I'm really glad you're here, honestly. Wow. That's great. Wow. Everyone, Flame, that's Flame for you. And I'm just casually here chatting with you. What am I doing?
What do you mean?
Mean?
No, it's just like experiments in a course. That's all it is.
Oh, but still, oh my goodness, wow. That is cool, that is really cool. I don't know what to say, honestly. How am I gonna follow that one up, huh? I made a video or something, I don't know. I don't do cool things. Damn it. That's really cool.
I mean, I'll have a lot more to talk about when I do my research. That will be a fun time.
Keep us posted. I do want to start the. I do want to start the series of videos, previous papers, and I would absolutely love to be the first reporter to cover on your paper.
Oh, I mean, it's not gonna be like my paper. It will be like my name kind of thrown in because I did some like experiments and stuff.
By that I consider that your paper still.
But yeah, it would be. I assume it would be published in like a few years.
Yeah. So what do you mean it wouldn't be exactly your paper? Not the,
Well,
well, you may not be the one you know
I would
who's
be on
actually...
it among many names
Yes, it was.
because
So
I
still,
contributed a bit.
not organizing it, but it's still like
Yeah, I guess.
doing the research.
Yeah.
That's what
Have I
I
told you
find
about the research I'm gonna do, like what I'm actually doing?
with the vanadium.
That's the project I'm aiming to do next year, like for my year-long
Then-
project after summer.
Then I don't know exactly.
So it's like the one I'm doing this summer is the same kind of thing as the vanadium stuff. Like we're doing the same techniques, but with a different complex. So it's like basically my professor, she's already made these cobalt complexes that kill fungal cells, which are like cause fungal infections. And what she doesn't know is exactly how they kill the fungal cells. And so she's done these cobalt complexes that have this this ligand on them, and they do this stuff. And for my project, I'm essentially sticking. So I do some click chemistry first. Like I put this alkyne and this azide on these two things, and I stick together the complex with a fluorescent organic molecule. And so I stick that on the complex, and then we put them in the fungal cells, and we do loads of measurements, including this thing called fluorescence spectroscopy, which I guess you use to look at the fluorescent stuff. And we basically just see what they do in the cells. So we analyze like the mitochondria and all of that, and and see where it's going in the cells and how they're actually dying to the complex. So it's like pretty simple, but it's like a 6-week project because we have to do all these different reactions and stuff.
I mean, okay, I know why you mean like it's like pretty simple. I get what you mean.
It's simple to say, like we put a tag on it and then we see what it does.
Yeah, it's simple as in you don't really have to like invent a new way to just check it. As in, yeah, in that way. I mean, yes, that's true. It's simple. It's just a very interesting way to put it.
Well, I mean, so the project I was going to do next year with the vanadium is essentially like the same thing, because instead of a cobalt complex, it's a vanadium complex, and instead of fungal cells, it's cancer cells, and instead of sticking like a fluorescent organic molecule onto the complex, what we do is we stick the complex to fluorescent gold nanoparticles, and we talked about nanoparticles already, and so that's even cooler. Because then I get to do all this nanochemistry as well.
Wait, actually,
I haven't done before.
When it comes to nanoparticles, how are they made actually? Is it like a general way they are made, or is it specific
there's
for
like
every single one?
Oh, I actually don't know. So I know that basically there's this professor that works on nanoparticles, and so this project would be a joint project between my current one and this other nanoparticle professor. And so she knows exactly how to make them and like the perfect methods to use and the perfect sizes and all of that. So she would know. I don't actually know. I mean, I assume it's different for different ones because, for example, quantum dots are like superconductor nanoparticles, which have obviously got more than one element in them. And I assume it's made really differently. But yeah, I don't know. I haven't looked too much into it because we haven't covered like any nanochemistry so far in my degree. Next year is like I spend like a whole half a module doing nanochemistry, so I get to learn it all then.
Honestly, you got me wanting to do something. Honestly, you know, you really. Hold on, let me check. No, my electronics still didn't arrive. They still deliveries after midnight. They might have arrived soon then. Because I feel dumb.
Yeah, okay. The thing is though, like this is all like these are things that have come up. Like these aren't things I'm good at. These are things I've been given to do. You know, like
these are essentially things I'm good at.
All the work
I do.
Yeah, like all the work I've done is like pass some exams and do well enough to stay on the masters, to switch to the masters course, and that's it. Like that's all I've done. And then I spoke to a professor, and she was like, "Oh yeah, you can do this project," and then we did it. So
I
it's
mean,
like,
you clearly know your stuff. So I
well,
don't think you should really. I feel like you're undervaluing yourself right now. Yeah, all I did is just roll a couple of things down, and one thing leads to another, and here I am. Yeah,
well,
don't
I'm
mind
saying that like
all
anyone could
my
have. I
quantity.
feel like anyone could have like gone on the course and got to where I am.
Yeah, I mean, well, yeah, I mean, technically, yeah. That's like saying, oh yeah, Nobel prizes aren't that. I mean, anyone could
Well,
have gotten them if they just tried hard enough. Like, yeah, they could have. That's kind of the point. They didn't. Don't
yeah, I
undervalue
guess.
yourself like that.
I mean, to be fair, like my course in the first year at the beginning, we had like 100 people on the course, and now at the end of the third year, we're down to like less than 40 people, which is insane. Like they've all in first year, like all these people dropped out because they realized chemistry wasn't for them, and then in second year, all these people either like had to retake the year or got kicked out because they did badly on the exams, and so it's like it's really thin the numbers, and now and for the like integrated masters next year, it's only like 6 of us who are actually doing it, which I think is crazy because it's just basically me and my friends, and that's it.
6. That is really low.
Yeah, I think we'll get more people from like other chemistry students who are like joining in to just do a master's degree. But in terms of like the people in my current year who are continuing for the integrated masters, it's just 6 of us out of less than 40.
Yeah, and you're like anyone could have done it. Well,
Well, okay.
I just don't want to undervalue you because listen, I'm not giving you the correct feedback in this on this stream, and I want you to know that I know, and I want you to know that I know that doesn't matter to meta. The point is, I'm not giving you the correct feedback on this live stream because the point I don't like. I understand what you're talking about. That is true, but I'm not
Yeah.
good enough to actually constructively comment on it in any way.
Yeah, I get what you mean.
Yeah, I'm just here, no,
Yeah.
and I don't get me wrong. I love hearing about this stuff, but I'm just here nodding my head because there's nothing else I can say. Like, wow, that's
As a
cool.
thing though, like I talked to my mom about this stuff, and it's like I had to break down loads of stuff to like get her to understand it.
I mean, you're breaking
'Cause
down really well.
it gets so advanced that like you can't talk to a normal person about it if they don't know science.
Yeah, I get why.
And it's
But
like my
I
brother
think you're
talks to
breaking.
her about history because he's doing a history degree, and it's like she can understand everything he says, but when I talk about mine, I have to like try really, really hard to explain it.
And that's an injustice. That's
Yeah.
we need to correct it. That's why I make videos.
I mean, yeah, like
Number
science is
reason.
kind of gatekept a bit,
It
but
really
not a
is.
bit, like, a lot
It really is. I mean,
behind all this terminology and stuff.
I don't. I think the most gatekept is the programming community, in my personal opinion. But that's
True.
because I feel like scientists do it on accident. Programmers do it on purpose. That's just
Yeah, I mean, actually, that's a good point because like a few weeks ago, I was like talking to my mum, saying like, "Oh yeah, we make this molecule and we do this," and as we were talking, she then said like, "What do you mean by you make a molecule? Like you make a molecule?" And so I had to explain that like I'm not talking about making one molecule. I'm making like a whole sample with Avogadro's numbers amount of amount of molecules in there. And it was like, it just completely caught me by surprise because it's something I just completely taken for granted. But actually, it's a fair assumption from her that if I'm just saying,
yeah.
well, you make a
Make
molecule,
molecules.
it's like,
Actually, I didn't
yeah.
know it either. I would. I mean, I always had also just make a molecule. I guess.
Yeah, it's just when I talk about it, it's like, we're making a solution full of, billions,
Oh, I guess
more
that
than
is
billions.
true.
Yeah.
Like when you say, "Oh, it only now hit me that when someone says
Yeah.
make a molecule, if someone has no idea, no, that doesn't know, well, not has no
Yeah.
idea, only doesn't know chemistry, they would probably just imagine like extremely high tech machinery,
Yeah.
splitting atoms and then merging them together."
And then she asked questions like, like, oh, how do you know you've made this molecule? Like, how do you see it? How can you tell what you're doing? And it's like I then have to explain stuff like NMR spectroscopy, EPR spectroscopy, and all of that, and it just gets really complicated because it's like we don't actually see the molecules. We just see all these
Yeah,
properties that clue us in to what we've made. But yeah, science communication is hard because stuff just gets so detailed that you
yeah. I mean,
like it
that's what I
requires
meant.
all this other understanding.
That's what I meant. Scientists do it on accident because for scientists, if not using terminology is very difficult
Yeah.
when you're
Well,
doing.
because the thing is as well, like when scientists communicate with each other, it's way more efficient to communicate using this terminology because we know that all the other scientists have this
Yeah.
understanding.
So, for example, reason. I mean, it's not the best example, but IUPAC, right? That's a pretty good one. Like,
Yeah. Yeah.
yeah, cyclohexane, for example, it does sound a bit scary, and that's not even one of the bigger ones, but it does sound a bit scary to an outside observer. But it obviously is convenient because
Yeah.
other people don't even have to memorize these things. Like from an outside observer's perspective, it really looks like you just know all of these molecules. If you just,
Yeah,
it
exactly.
really looks like you just memorize them. But once you actually get into it, then it does make sense. Also, a similar thing
Yeah.
with, and that's in every shit. So yeah, the reason why in medicine also there are so many things. People always think that medicine's about memorizing stuff, and yeah, it
Yeah.
is. But people get it wrong. It's not about memorizing the names. It's about memorizing the things that happen.
Yeah.
The names are the
I mean,
easiest bit.
I did some medicinal chemistry last year, and that was like, it was from like a chemistry perspective into medicine. But there wasn't the memorizing was like memorizing reactions and like properties of
Yeah,
stuff. It
precisely.
wasn't there was no memorizing names.
Yeah, names are kind of obvious because names
Yeah.
also there's also conventions, so that's nice. What I found really annoying, I remember when I was learning medicine, what I found really annoying. I was doing it on Daishim, the textbook, as always, but like, uh, the initial chapters were mostly about biology and biochemistry.
Yep.
And there were like 7 different terms just for water related, like increase and decrease of water. There were like 7 different descriptions of
Yeah.
the exact same thing.
Yeah.
And it was I think 3 chapters were just dedicated to, oh yeah, here's how water can move stuff.
Yep.
It's very upsetting. But that's why I really like things like, for example, Free Blue and Brown. I'm a huge fan.
Yep.
Because when people see an integral, the first reaction is always fear. I mean, it's an integral, it's terrifying.
Yeah.
But once you realize what an integral is, it doesn't really look terrifying. It looks kind of, it's an integral. It just looks mild. That's why I like. That's why I want to make some science vids.
Yeah.
It's my catchphrase. It's basically my catchphrase. It's simple. It's simpler than it actually is.
Yeah.
Actually, than you think it
But yeah,
is.
that's why I was so happy seeing like your chemistry video pop up because it's like, oh, when I saw the thumbnail, I was like, oh, he's actually gonna explain this stuff in a visual way, which is really you don't see much of it because it's hard to make
Yeah.
animations
And then
stuff.
you've seen the video and you were like, oh, he actually explained absolutely nothing.
Well,
I'm really upset with that video though because I really did explain nothing. I explained the basics.
yeah, I mean, I looked at it and I was like, oh, this is exciting, and then you went into basics, so I was like, okay, it's like an introduction into the stuff.
Yeah,
But I'm glad you're going into more depth now.
I have to. I can't sleep well at night. How am I
Yeah.
supposed to sleep well at night knowing that this is my chemistry video, the chemistry video? I can't. The electrochemistry video would be much better. I'm gonna tell you, the electrochemistry. I feel like with the electrochemistry video. Okay, when it comes to chemistry aspect of electrochemistry, you won't learn a single thing. You already know all of this. But moving into the high abstraction, even you might learn something cool.
Yeah, I
Yeah,
mean,
because-
I've covered like bits of electrochemistry.
Yeah, but your bits of
and I've
electrochemistry is
forgotten those
more
bits.
than most people learn their entire
Well,
life.
okay,
So
yeah.
yeah.
Well, I mean, yeah, I was showing you like superconductors and semiconductors like the other day, and so I do know it, but I do forget stuff, and so seeing these videos does remind me of stuff.
I just feel like organic chemistry will be a slam dunk of a video because the only thing that like the thing keeping people away is the visualizations.
Yeah, especially if you're, I don't know, organic is hard to show. I'm trying to think.
They are just
In
large.
terms of like organic reactions, like if you're going proper full organic, it's like it's all about these different organic reactions, and those are all a case of just where the electron density is going. Essentially,
Yeah.
it's like you have something that's electrophilic and something that's nucleophilic, and they react, and and you have your conjugated pi systems, and the electrons will jump around in those pi systems, but it's all it should be pretty easy to show in an animation, and it should be really nice for people to see because they can then see, if you're coloring them, for example, they can see these colors move around, and it becomes really intuitive because in their heads they know that the red attracts the blue, and so then they see them come together, and it's obvious. So I think that's really cool.
Yeah, I'm glad. I'm not useless. Yay. That's basically the
Although organic
conclusion.
is the thing I can help with the least, I think, because organic is my main weakness.
I mean, right now I'm
I
still.
failed my organic exam last semester, so I have to retake it in the summer,
No. I mean,
which is rough because I got like 35% on that, and we needed 40 to pass. And for
oh,
literally
Christ.
everything else this year, I've got above 70. So it's literally like 70, 75, 73, 76, and then down there is like 35. It just doesn't look great.
Well, yeah, I suppose. I mean, right now I'm in a very nice spot for you because right now I'm moving from quantum mechanics to chemistry,
Yeah.
and I feel like that's your golden spot.
Yeah, I mean, this is the stuff I really like.
Yeah, I
Yeah.
feel like that's this video, the electron. That's gonna be.
Because I don't know if I mentioned, but like when I started at uni, I was on a chemical physics degree, not on chemistry. And
I think you mentioned it
I might have
once.
mentioned it in chat or something.
Yeah.
So I essentially I joined the uni on this chemical physics degree, which was meant to have actually been deleted by the uni, but there was some admin error and they hadn't actually deleted the course, and so I ended up on this course, and I was like the only person on it, and on the course it was essentially like the normal chemistry modules with a physics module that was optional in the chemistry module, and then an extra maths module. And within like the first few weeks, I was like, okay, I hate this maths module. Let me just switch to chemistry. And so I switched to the chemistry one and kept the physics module. And then I gained this other like really easy chemistry module. But I kind of like approached uni thinking I was going to be doing like physical chemistry, chemical physics. And so I always had like a lean towards the physics side of chemistry. And then I took like two different quantum mechanics modules, which, to be honest, I kind of suffered in those. Like it does, the maths is not fun, and it's a bit too intense for me. But like I found the theory interesting, and it let me understand a lot of other stuff in chemistry a lot better because it's like this stuff that we looked at in quantum mechanics that we worked through the maths for and came to these conclusions based on the maths. Those conclusions were then used as like foundations for other stuff that we were taught in chemistry.
Yeah,
And so I had this like extra understanding that my friends didn't have.
that's also what I think people don't realize, that quantum mechanics and chemistry basically deal with this very similar like sizes of things. So
Yeah.
obviously, so when you think of chemistry, you just think of mixing liquids together. When you think of quantum mechanics, you just think like a massive board filled with numbers and capital sigmas and them integrals and stuff like these. And what most people don't realize that they both just deal with like subatomic. Quantum mechanics is more leaning towards subatomic, and chemistry is more leaning towards atomic. But it's both practically the same size. So obviously
Yeah.
there's going to be a huge overlap.
Well, yeah, I mean, in chemistry, it ranges from subatomic to multimolecular, so
In chemistry,
it's
it
a
ranges from
range.
subatomic to just a 1 kilogram piece of rubber.
Yeah, I mean, yeah, but that piece of rubber is like one molecule, so
Technically, you see.
yeah.
Yeah.
It was funny. I think I got really lucky though with that whole chemical physics thing because I think if I'd actually just tried to get on the chemistry course, they would have rejected me because I had a C in chemistry. So I
Listen,
think I actually like snuck my way
that's
in.
called destiny, alright? Like I
Yeah, because now I'm doing a master's, so
yeah, that's love at first sight, no love at first mistake from the higher up.
yeah.
It's destiny.
It's actually crazy. Like the actual the way it all came together. Like when you think about it, like the odds of all that stuff happening.
Yeah, and yeah, you're here like, oh yeah, anyone could do it.
Well, okay.
Come on, man.
Well, anyone could have got better than a C. You know, I just didn't really try at school, and then we got messed up with COVID because that cancelled our exams, and it just kind of messed everything up. So yeah.
I just think personally, honestly, wait, I don't think I shown it on stream while you were here, but basically, I have my own favorite curve because, of course, I do. Of course, I'm the kind of person who
A
have their own
favorite curve.
Yeah, which basically,
Favorite curve.
yeah, it's my favorite curve, because I'm the kind of person to have a favorite curve. But basically, it looks like this, and it's basically like a graph representing of how much people know to how much they think they know. I
Oh
just
yeah.
honestly
yeah.
think you're right here. Honestly,
Well, it's like as you learn stuff, you learn how much you don't know.
yeah,
You know.
then only when you know things, you know how much you don't know. Precisely.
Yeah, and like I talk to all these professors, and they just know so much more than me, and it's just insane.
Yeah, but that's precisely what I'm saying, right? That's why I think you are right here. I myself think of myself like right in this spot. There's my sweet spot where I am most of the time. That's where I am for my quantum mechanics, my chemistry, my maths.
Mm-hmm.
That's my little. I like it there. You know, it's comfy, it's cozy. You don't have to. I can go downhill if I want. I'm not all the way down, so if I ever needed to go uphill, I can. It's versatile. Because I think like that's just the reason why. Just you are doing cool things, and the fact you get them, that's still insane.
I mean, I get some of them. It's like I get them when they're explained fully, but sometimes I can't get something if it's just like if I just have to work it out from nothing. You know.
Yeah, but you have time, right? Like
Yeah.
these
yeah.
professors, I don't think, I think it took them a while to get the point where they are.
Yeah, that's true. That's true. Yeah. There's this one professor that just like the stuff he's like interested in is like the exact same stuff I'm interested in. And so whenever he teaches stuff, it's just perfectly aligned. And
that's
he
always
teaches
so
it in
nice.
such a perfect way that it's just like completely on the same wavelength. Like my brain just follows everything through absolutely perfectly, and it's so satisfying.
All right, I'm gonna go. I think 2 hours 40 minutes.
Yeah, that's fair.
That's
Yeah.
long. I have to force myself to sleep, cause
Good luck.
yeah, I mean, tomorrow I have to wake up, relatively early, and my only two options are either I go to sleep right now or I don't sleep. There's no really good options in between. Oh, I wish most of these drugs were legal and free. Make life so much
You
easier.
want me to make some for you? Is that?
I'm just saying, we'll make my life a bit easier.
Mm-hmm.
Anyhow, well done, everyone. Thank you, Flame, for joining in. And as always, feel free to join anytime. If I'm alone,
Yeah, I mean, I feel like I don't want to join and bother you when you're doing your own thing.
I'm never doing my own thing. I'm absolutely
Okay.
never doing it. Like, if you don't feel disrespected by the fact that I'm doing animations in the background, because I can actually listen and walk at the same time. If you don't feel
Yeah.
disrespected by that, then just join anytime you want.
Okay.
Because then, like, when I'm doing a Tetris stream, that's not really like
Yeah.
high priority.
Yeah.
Or if I'm researching capacitors or something, I could research that in 15 minutes. It's just that I just stretch it over 3 hours for content. Anyhow, well done, everyone. Thank you, everyone, so much for watching, and have a great day. Bye.